So hi there. It's good to see you all. I'm glad you came. My name is Rafe Kaplan, and I'm going to talk to you a little bit about developing collaborative applications on Google App Engine. I'm going to first go into a little bit of an introduction, explain what is required of a collaborative application, and what kinds of mechanisms you might build in order to support a collaborative applications. And then I'm going to talk about specific implementations that you might use in developing a collaborative application. In particular, I'm going to talk about resource locking and a very simple publisher-subscriber model. So with a collaborative application, users need to be able to share and edit common resources. Now, these resources might be a document that everybody is working on, or it might be a blog or a journal or some other kind of collaborative forum. There needs to be some kind of coordination between the users so that they don't, clobber each other's work and changes. And these changes, when they occur, they need to be communicated quickly between the users so that people know when updates are available. There's a couple of models for resource sharing that we might go for in an application. One model, probably the simplest model, is to have no type of user coordination at all. Now, it might be, what this means is that users might work on the same shared resources, and on occasion there'll be conflict, and one user might overwrite the work done by the other user. Depending on your application, this might be acceptable. This is a very simple, and if you don't need to have user coordination, then why add the complexity? Another model is that we can have it so only one user can edit a given resource at a time. In this model, a user comes and acquires a lock for a resource, and no other users can edit that resource while that resource is locked. Probably the most sophisticated model you could have is when multiple users can change a resource at one time without clobbering each other's changes. They really have like true collaborative, collaborative work being done. An example of an application that uses this is the Google Apps. So, for example, if you're working on a spreadsheet and you have other people collaborate with you on the spreadsheet, you can actually see their cursors on their on the web page, commingling with yours, and you can see updates as soon as they add them to the spreadsheet. Pardon me. So, if you're going to pursue a resource locking mechanism, you need to have it so that a user can become the sole editor for a given resource. This resource lock needs to persist across multiple requests. It might take them a while to make changes to the thing that they're editing, like it might take 5 minutes. So you need to have something that persists across requests. And so, for example, a data store transaction isn't sufficient for providing this lock, which wouldn't make sense anyway because data store transactions don't lock resources anyway. The changes that occur ideally would be atomic, so that you don't see changes halfway through. So if when somebody's done with their edits, the complete final work is done, and they don't see a half-edited piece of work. The lock has to be released when the user is finished changing the resource, and if the user sort of closes their browser or goes to lunch or just rudely takes over the resource for too long, that resource lock needs to eventually expire. And if the user wants to make edit changes again, they're going to have to go and reacquire the resource, which of course might have been taken by somebody else. The publisher-subscriber model is also going to be thought of as having resource watching. So users are interested in changes that occur to a resource, and they're able to subscribe to be notified about those changes. These notifications need to happen in a relatively timely fashion, and a user needs to be able to freely sign up and to register to start and stop watching a resource at any given time. The users when users watch changes, they also want to remember what changes they've seen. So if you think of, a good analogy would be if you join a mailing list, and you might participate in conversations on this mailing list, and after time, maybe you lose interest in the topic or it's no longer relevant to what you're doing, and you unsubscribe from the mailing list. You don't want all of your emails that you've received to disappear. You want to have a record of your email in your inbox that is associated with that list. So ideally, a system that has resource watching will let you record, remember those changes. So let's talk about writing working on a very simple collaborative application. Probably one of the simplest collaborative applications that people are familiar with is a basic wiki. So the idea here is users create and modify these wiki pages. And in this case, the collaborative resource that people are sharing is the wiki page itself. So when a user starts editing a wiki page, you might want to lock that wiki page so that nobody else can come along and edit it. Because if two people are making changes at the same time and then one submits, the next time that the other person submits, it'll overwrite that other person's changes, losing all that information. You still want users to be able to go and view wiki pages as they're being edited. And when the user completes working on the wiki page, that's when the resource is released. That's when the lock on the wiki page is released. Another feature you might add is that people can register to view changes to the wiki page so that they receive updates when a wiki page they're interested in is changed. So let me give you a quick example of seeing a possible simple wiki application in action. Okay. Here's a typical front page of a wiki application. So the page itself is simple text, and you create links to other wiki pages by writing words in camel case. Like for example, here we have Shahrukh Khan. And apologies if I butcher the names of your favorite actors. You can click on a link here to go and find out about his films. That's not right. There we go. Okay. So here's a page that we've written about, about this actor. Has information. But let's say we want to add more information to our wiki. So let's go and create it. We want to create more information. We're going to edit the main page and create another link to another type of resource. And bear with me, my memory is short these days. Right. So we're gonna add a little bit of information about Sachin Tendulkar, and there he goes. It appears as a link. When we click on this link, it takes us to an editor so that we can fill in information. Right. So now we have information about an excellent cricket player in India. So that's the basic functionality that we're looking for in a wiki. And we'll get to the more collaborative aspects like the resource watching very soon. So when we start off writing this application, we need to define our wiki pages in the App Engine data store. You can do this through the Model API. Since the wiki page is going to be the basic shared resource of our application. We want to have a little bit of additional information that's associated with the wiki page in addition to the content of the wiki page. We want to have we want to know when it was created, when it was last modified, and it might even help if we have the last person who did the edit, so that you can track them down and blame them if they add information that's not correct. A little bit of details about how the application is going to look from the browser's point of view. The wiki pages, as I demonstrated, are described, are linked, the links on the wiki pages are described using camel case. And the public URLs are such. Going to the home page just redirects you to /front page, which happens to match the pattern of /wiki page. And that's how you basically go and view a wiki page in this application. If the user logs in, they'll be able to go to other wiki pages. They'll be able to go to other URLs, such as the edit wiki page, a page that will allow them to watch and unwatch given wiki pages, and a special home page that will show them information about recent updates to the wiki page. It'll show them things like the top 10, the 10 most recently pages across the entire wiki, the 10 most recent edits that they made, or the 10 most recent pages of the pages that they are explicitly watching, the pages that they've subscribed to. So for the first part of the collaborative mechanisms, let's talk about a resource locking mechanism. We're going to implement this particular resource locking mechanism using the App Engine data store. So what does this kind of lock look like? So what we're going to do is we're going to create a separate lock entity to represent each lock for a given wiki page. Now, it's very important that we have a separate entity for the lock, because in the case of when you are creating a page, that page doesn't exist yet. So we can't just simply lock on the wiki page. So we create a separate entity that represents a lock of a non-existent page. Well, we can't use transactions in this model to implement the locks, as I mentioned before, but we do use transactions for creating and making sure that the locks are managed in an atomic fashion. The other part of the structure is we're going to make the actual wiki page. We're going to make this new lock object the parent of the wiki page that it's associated with. And this will enable them this is how they'll become part of the same entity group and, the same transaction group, and they'll be able to coordinate their actions through a transaction. So let's take a look at what the wiki edit lock model will look like. It's very simple. We have a user property that represents the editor, and we have the expiration. Next, I probably should have used a better variable. Expiration is a little bit misleading, but that will be the time when the lock was acquired. So what we can do is we can determine if a lock is expired by determining the difference between when another user tries to acquire this lock and when the lock was acquired. And if that difference is larger than the expiration date for a wiki page, in this case is probably about 5 minutes, then we know that this lock is expired. Well, let's see how do we do that calculation. We can add a method to this model that will actually illustrate how the lock is, how we determine if a lock is expired or not. So in the simple case, in this, if the resource has been explicitly released, the user has finished editing the page, and they release the lock, they're going to set the expiration to none. So if the expiration is none, then we know that the resource is expired and it's available for acquisition. Otherwise, we're going to calculate the difference, as I described. We're going to get the current time, subtract the edit lock duration from that time, and see if the overall time elapsed is greater than the expiration. Actually, yeah, I think. Another method we're going to add is a class method, which conveniently allows you to just attempt to acquire a lock. It'll return true if you successfully acquire the lock, and actually it'll return the lock object. It'll return a wiki edit lock object if you successfully acquire the lock, and it will return none if you don't acquire the lock and are not able to continue editing. So what we do is we try to get the edit lock by a key name, which the key name for the edit lock will be the wiki page itself. If that lock exists, if the lock does not exist, we create a new wiki lock because this is going to be a new page. We then get the current user and then we check it to see if the lock is expired. So we're going to acquire the lock on behalf of the user if the lock is expired or the current user is the user who has already acquired the lock. So you can acquire your own lock. If you acquire the lock, you set a new expiration date, which is going to be now, and then you set the current user to the editor, the holder of the lock, and you return the lock. Otherwise, you return none, as I mentioned before. When you want to start the edit, you need to first acquire the lock, and this is what it's going to look like. So this is a handler. This is a get method on a request handler using our simple web app framework that we provide with App Engine, and we've set up the URL for, say, the edit URL, so that we parse out the wiki name and pass it into the get function. The first thing you need to do is always CGI escape your user input. If you don't, you can open your site up to some pretty nasty scripting attacks, and you really don't want to do that. So I can't emphasize that enough. I know it's not relevant to the talk, but it's worth mentioning. We're going to write a simple function that tries to acquire the lock, and if it acquires the lock, it'll save the lock. So it calls the acquire lock method. If the lock comes back as acquired, we save the lock. We know that we're going to be the editor, and that user is going to be the editor, and we put it into the data store. We then need to wrap that in a transaction so that it's done atomically. And if we manage to acquire the lock, then we're going to show the editor. If we don't manage to acquire the lock, we actually redirect the user back to the original wiki page with a little bit of extra information so that we can display an error message that says something like, the user, the page you attempt to edit is already being worked on by another user, so that the user knows that they tried to get the lock and they couldn't. Now when we save the page, we need to acquire the lock again. And this is important because, if the user's lock has expired, we need to tell them that they can't save the information because they took too long editing it. It also could be that somebody's trying to do something weird and has written a simple program to automatically write the URL for, spamming wiki pages, and they might not have acquired a lock at all in order to do that. So we still might need to block them. Again, if we manage to receive the edit lock, we try to get the wiki page by name, and then again the key name for the wiki page is going to be the wiki page itself, the name of the wiki page itself. If we don't get a wiki page, we create a new wiki page. Now notice that the parent of this wiki page is the edit lock that we've acquired, and that's how we're able to make it fit together in a transaction. Then we get the content, CGI escaping, of course, and we set the last editor to be the person the user who last edited it, and we put the wiki page into the data store. Then we clear the expiration on the lock and put that into the data store. An alternative is we could actually just delete the edit lock. That's okay too. But in this case, I just thought it would be just a little clearer to do an expiration, explicit expiration. This save page returns true or false depending on whether or not it was successful, so you can, determine if, give a message to the user whether or not they successfully edited the page. This version of the resource locking mechanism has a couple of disadvantages. For many applications, this might not be important, but if you have a lot of data store rights that come with creating data store locks, these data store rights can add up over time and start chomping away at your quotas. Depending on the complexity of the resources that you need to lock, this transaction can be very long and expensive. You want to avoid transactions where you can. It's also hard to garbage collect unused lock entities. So, again, you could have, when the user explicitly expires the lock, you can just delete the lock entity and it doesn't matter. But in the case where the lock expires because the user runs out of time. It's really difficult how the system is written right now to go and garbage collect all those little tiny lock objects. In practice, this may not be a concern, but but again, it is data source space that you're paying for, and you don't necessarily want to have tons of leaked objects that don't serve any purpose in your system, right? So there's another way to do resource locking. You can use the Memcache API that overcomes some of these limitations. What does this look like? Well, for one, you don't need to have an entity explicitly for locking, so that entity goes away completely. It doesn't require a data store transaction at all. You don't have to have any. And the Memcache records can be set to automatically expire. So even if the user, goes to lunch, closes their browser, goes to lunch, that Memcache entry will not stay around forever. We're able to do this because and we're able to use Memcache to do this kind of atomic locking because of how the add operation works in Memcache. And I'll talk a little bit more about that later when we get to the code that actually does it. So when you want to acquire the Memcache lock to begin editing, I'm sorry. Now we're going to define a function that is used for that the application called to attempt to acquire a Memcache lock. Right? So the first thing you do is you get the current user that's going to attempt to acquire the lock. We're going to add a little bit of information to the user's string to the page name to indicate if you're going to look at all of your Memcache keys, just to give you a little bit of extra information so you know what that key is for. And then we're going to call Memcache get. And if a user has a lock, then that user's username will be returned as the lock. And we can then compare to see if that user is the same as the currently logged in user. If it's the same as the currently logged in user, great, we've acquired the lock, we return true, all is well. If it's not, we then can attempt to acquire the lock. We attempt to acquire the lock by calling Memcache add with the lock key, the user as a string, and a duration, which in this case happens to be 5 minutes. But the way that add works is it only will add information. It'll only set the value in Memcache if it doesn't already exist. So if another user comes along and has acquired that lock, and then you try to in the space between when you originally checked to see if the lock was acquired and when add gets called, it'll return false because add doesn't let you update information that already exists. And then you know you haven't acquired the lock. Otherwise, if the lock owner is none, then you can't acquire it. Is that right? No. So when you acquire the lock to start editing, it's very similar to how we did it in the data store based log. You CGI escape the page name of the wiki page, you acquire the lock, and if you manage to acquire the lock successfully, you show the page, and if you don't, you redirect it back to the user. Now notice we don't have to worry about doing anything in a transaction or calling put when we're done, because it's all handled a little bit simpler by Memcache. When we want to save the page and release the lock, again, it's very similar to the other mechanism, to the previous the data store mechanism. We first need to acquire the lock again, try to look up the wiki page. If the wiki page doesn't exist, we create the new wiki page. We go and get the content and set the content, set the latest user, and call put. And then we call Memcache delete, and that'll release the lock. It's very simple. Now the lock is available for other people to claim. The disadvantage of this may not be very serious. Technically, when you do the final edit, there might be a period of time where it's not completely atomic, and you could, in theory, get one user to override the other user. But in practice, this really means that the user would have to acquire the lock, make their edit, and submit their edits like in a matter of microseconds. So in practice, for most applications, this is okay, unless your website's under attack by some hacker and This is probably not proof against that, but that's probably not a very realistic threat model. Another problem is the way that memcache works is that there's no like this duration you set, there's no guarantee that that will be honored. The memcache values can be evicted from the cache at any time. So what will happen there is a user will acquire a lock, they'll do some editing, and they might finish in less than 5 minutes, but on occasion, even though they might have finished in 3 minutes, if the lock was evicted, they may not be able to acquire the lock if somebody else has come along and taken that lock again. All right? So let's see this. Let's actually see if we can see this in action. All right? So I'm going to get two browsers up this time. We'll start with the original one, the one that we were looking at before, right here. And let's say we're user one, and we're going to come and make an edit to this page and add a little bit more information. So we've now got up the editor, and when we called edit, we've now acquired the lock, and we have 5 minutes to edit this page. So along comes another user, and this user likes to use Safari instead of Firefox, and they log in as somebody else, and they go and they want to add their information to Sachin Sendilkar, and they come along and they hit the edit button, and it doesn't let them edit. Now, there's a little bug here, and I apologize. It should show the error message that says this lock has been already acquired and you can't edit it right now, but it doesn't. So let's go back to the other page and let's finish this edit, right? Right. We're done with our edits. We hit save. And now we go back to the other user, and now we're able to edit the page if that's what we wanted to do. Okay, so that's basic resource locking in action. So let's talk about how to implement a very simple publisher-subscriber model. So how do you know who saw what changes? How do you figure out how to have users subscribe to a wiki page to know about updates and be notified when changes occur? Normally in a publisher-subscriber model, a user is able to subscribe to a number of different topics that they're interested in receiving notifications of. In this case, in this model, the topics are the wiki pages themselves. Pardon me. A user may watch many wiki pages, and a given wiki page may have many watches. So there's a many-to-many relationship between the resources being watched and the watchers themselves. So let's define a model let's update our wiki page model to be able to handle subscriptions. So this is the wiki page model that we saw before, and all we do is we add a list of watchers that are going to be user objects. And so if somebody comes along and wants to watch an individual page, the application will add that user's information to the end of that list. And similarly, when the user wants to unsubscribe, they get removed from that list. We then need to add another type of model of entity, that records changes when they occur to a wiki page. So what we're going to do, it's going to need to remember a copy of the subscriber list on the wiki page at the time that the resource was saved. And that's so that it will behave in that sort of mailboxy-like way that I described when you have when you subscribe to a mailing list. So remember who was subscribed at the time of the update. You're going to add the editor to get a little bit of extra information of who made the change. And again, you're going to have another list property that's identical to the previous list, to the list property on the wiki page model that is going to be a copy of that list at the time of the update. So then we need to generate the notification. We generate the notification when we save the page. Everything else pretty much looks the same as before, We'll create the wiki page when necessary. And this time what we do is we create the wiki edit entity. And we set as its parent the wiki page that if we wanted to, we can do transactions. It may not be necessary in this case because usually in practice, the locking mechanism is usually enough to avoid transaction problems. We set the page name, we set the editor, and there we just copy the list of watchers over to the wiki edit object. Everything else works the same as before. Now we want to know how the user sees the change. So we're going to have a home page where users can go and see a list of the last 10 edits that were made in the entire wiki, the last 10 edits that they made in the wiki, and the last 10 edits of the wiki pages that they're subscribed to. We do this using a GQL query. We're going to always query on the wiki edit, and that's why it's very important that any other additional search information that you want to place on the wiki edit entity, such as maybe you want it to allow them to search on the title of the wiki page, then you need to add that. You need to duplicate that information on the wiki edit object. But in this case, all we need to do is search against wiki page, filter by editor, which is going to be the current user, order by the date that it was updated, and limit it to 10. Next, we're going to get the 10 most recent edits across the entire wiki. It's a little bit simpler. We don't need to have a where clause. We just order by when and get the first 10. Finally, we're going to get the watched edits, and that's sort of like that's where the user is receiving notification of the edits through this query. We're going to look for wiki edits where the watcher equals the user. Now that might look a little bit strange because the watcher is a list. How come you're comparing a user string, a user object, to a list? But the reason we can do that is because of the way that equality against list objects work in the App Engine data store. It works a little bit. It really functions a little bit more like the contains method functions on a list object in Java. So we'll basically match any list that has that user, and it will match any wiki edit object that has that user in their watcher list. We can then put that into a map that we're going to pass along to our templates and display the home page to the user. And here I'll just give a demonstration of what this home page might look like. So let's go back to our original editor, and let's go to the My Wiki page, and that's what it's going to show. It's going to show that editor's 10 most recent edits and the 10 most recent edits on the wiki page, which happen to be the same because we've only done editing with this user. But right now we don't have anything in the watched edit list, so let's actually go and change that. Let's go back here. We're going to start watching this page. Now we've subscribed to the page. Let's go to the other user. And let's let this user perform an edit. All right? The edit is complete. Let's go back to the previous user and go back to my wiki page. And this time, I said this time. There we go. This time, we can see there's, the 10 most recent edit only reflects the 3 edits done by that user. The bottom, the 10 most recent edits reflects all the edits that have been done in the system, and you have your watched edit. So there you've been notified of the wiki pages that you're interested in. You've been notified of that change. Right, so there are some pretty there are a couple of problems with this implementation. right now, the way that App Engine is written, it might be a little bit limited for a very large list of subscribers. As you can imagine, a very popular wiki page might have thousands of subscribers. Like, they might want to have 40,000 subscribers. Like, if it's a national, wiki page, there could be a lot of people interested in the most famous actor in India. So whenever you write one of these wiki edit objects, you have to write in a large watcher array that is going to have as many elements as there are subscribers. In practice, this can actually burn up a lot of processor time and really ends up being feasible for about 1,500 users at this time. Not really too many more. Another problem with this is that if you have additional actions that you would like to associate with that update, you're going to have to do that many actions in return. So like, let's say you want to send SMS messages to people's mobile phones. Depending on what the SMS gateway that you're interfacing with, you might need to make, N calls. If there are 40,000 subscribers, you might need to make 40,000 calls to that web page in order to send a message. Probably the web page will let you send, more all at once, or if you're going to send email notifications, again, you're going to be restricted in the number of calls you're going to be able to make. You might also need to update other parts of your data model. So that could be, another thing that'll be very expensive and sort of infeasible to do in this model. Now, there's a possible workaround. It's a little bit more complex. You can shard the subscriber list so that there's a limited number, perhaps like 100 subscribers in each shard of the subscriber list. In this case, this means that what this means is that you can probably accomplish copying all of those subscribers. It's very easy to accomplish copying all of those subscribers into the data store in one request. So what you can do is you use the client side to help you out, and the client is able, has some, learns about what shards need to be updated when the edit is complete, and makes as many requests to as many shards as necessary to complete the subscription notification. Pardon? Some of the obvious problems with this is you then have to deal with a lot of the cross-browser, JavaScript compatibility headaches. But, again, these days I think people are getting used to that on the internet. A bigger problem might be that you can have a lot of fail requests, and if you don't have good error handling, a number of those shard updates can be dropped on the floor. Another problem is if the user closes the browser prematurely, then half of the subscriber list won't be updated. Depending on the application, this might be acceptable, so you have to consider it carefully. There is another alternative. You can change the rules of the game. You can find meaningful ways to change the requirements of your application so that a different type of publisher-subscriber might work. I think a really good example of changing the requirements is Gmail. Typically, when people develop Gmail email services and email clients, email gets organized into folders. But what Gmail did was, instead of having folders, emails can have one or many labels. And because they've done it this way, it means it was really easy for them to parallelize, filter processing. And it turns out, not only is it better for scalability, but it has really great benefits for the user, because if you work with labels, if you work with Gmail for a while, you get used to it, and a lot of users find that that's a really nice way to work with email. So this possible alternative, this possible reorganizing of the game probably is a little bit of a stretch, but you might not want to you might decide that it's not necessary to interleave the requests for the updates of the different resources. So right now, if you look at your update list, you might have an interleaving of updates of many different wiki pages. You might be able to separate that so you query against one wiki page, one watched wiki page at a time. It also might be easier if you place the publisher-subscriber relationship on the actual dedicated user object, because it's probably unrealistic. It's probably more realistic for a user to look at maybe, tops a couple of hundred pages than they are to like look at 40,000 pages, to be watching 40,000 pages. So you might be able to work with smaller lists if you were able to structure it that way. You could also, but that'll probably limit the kinds of queries that you can do. You might have separate, so in this model you would have separate lists on the home page of which resources are being, you'd have a list of the resources being watched, and then the user would select each one of the resources that to find out what the updates were for those resources. There's probably a few cases where this will be acceptable, but it's my futile attempt to give an example. However, the future looks a little bit bright. When we introduce offline processing, it'll be easier to handle large subscription lists. You'll be able to, take a little bit more time to process those 40,000 records, as long as your application can tolerate delays of a minute or so, or maybe even more. Maybe it's not even important, and you can have it go over half an hour. It'll also be possible when you're able to get better quotas, you'll have more time and more data store bandwidth to process these things with. Okay, so that's it for my talk, but I hope that you guys have lots of questions for me, and I'd like to answer them if I can. I can't give you a timeline when the offline processing is going to be released, but we're trying to do that soon. Aggregation functions? It turns out that those kinds of functions don't fit into a scalability model, like a scalable application. A lot of people, when they try to scale SQL applications that have those kinds of functions, run into problems. Because usually to do things like upper or compute averages, you end up in practice needing to have all of the information in that table in memory to process over it, or you need to page through it. You actually have to go and end up paging through all the data. Because we're trying to do something scalable and the data is distributed throughout Bigtable, that really doesn't become a feasible approach. But what you can do is you need to sort of have running pre-computations as you're building your model, as you're adding data into the system. And if you go to the articles page, I think that there's an article I wrote that talks about writing these kinds of SQL-like functions and building SQL-like model relationships, like one-to-many, many-to-many. And I think it also talks about aggregation functions and the kinds that you're talking about. Also, I think if you go to the Google I/O page, there's a really good talk by Brett Slatkin that may also shed a bit more light about why it's been designed that way and how to make things scalable. Right. Yes. That is the more scalable model. It's like memory is very cheap in relative to like processor time, and I mean that the data store can scale in that direction very easily. So you do have to do those kinds of computations. Like it does add more complexity to the application, but it's sort of like you end up having to do that if you do it using SQL anyway. If you wanted to import a bunch of data, well, what you should definitely do is check out the App Engine SDK. It has an application called the Bulk Uploader, and that actually does exactly that. It reads a CSV file and uploads it in chunks to your application. And I think that there's an article that describes how to do that on our articles page to set it up on the server side so that you can receive the data and process it correctly. It's not perfect, but it's a really good starting point to see how to think about those problems. Yeah. Mm-hmm. Yeah. Well, there's two ways. As I mentioned before, you can pre-compute as you build the data. That's often feasible for a lot of applications, but there might be a new kind of report you need to generate, so it may not be feasible for you to do that. Right now, I don't think I have a very good answer for you. But as we introduce offline processing, those kinds of functions will definitely be something you can do. You might also want to take a look on the internet. I think that there are people who are working on an open source version of MapReduce that I think works by coordinating between the browser and App Engine to basically break your information up in a way that can be processed in parallel and do these kinds of reports. But it'll be better in the future. Delete lots of records. I can't say we have a good solution for that yet. One really tricksy way you can do your tests is if you're working with models, you can override the kind method to point to a different kind for your tests, and you can increment that like kind 1, kind 2, kind 3, and the problem, of course, is that will use up data store quota, but you'll then have your production table will be clean. If you can, though, really try to do those kinds of tests on the dev app server if it's feasible. But again, like I understand that your application might have different requirements. Anything? We don't have versioning built into the model, even though an astute observer in the last session, knew that there's a type of versioning that goes on in Bigtable. But you can build it into your domain model. What would be interesting to see is as people have these, it can be basically built within the framework that we've given you. You can write your own versioning system. What would be interesting, though, is to see if people out there could come up with maybe the open source solutions that, which are libraries that make it easy for people who want to build revision-based domain models to make it easy. Basically, we plug it in, extend a class is like revisioned model, and the page. Yeah. Oh, is it integrated with those sorts of things? All right. I think it can be done in theory. I think that it depends. It depends on how the object relational mapping is done in those libraries. I mean, also like for now, because we only support Python. You can write your own authentication mechanism, yeah. Yeah. LDAP users, if you can, it might be a little trickier dealing with, I think, a kind of enterprise LDAP like you're describing, because we don't have a way to like isolate your application from like within your network, but you would have to, if you could interface with an HTTP, if you had an HTTP interface to your LDAP server, you could do that through URL fetch. But we don't provide libraries right now that make it easy for you to do this, but perhaps people have already done it. Yeah, we'd love to see stuff like that come out. Oh, as a Google app? Well, for social networking. Well, we don't actually provide applications like our objective is not to provide applications to the public. Our objective is to allow the public to write applications. So, I mean, if you can go, there's an App Engine app gallery, and you can see what people have already written. And I don't know, you know, if you go to the group site, here, using my application's IP? Oh, that particular one? Well, that application is, well, it's not deployed on the internet. I was actually using the dev app server to run that application, but it's not. You wouldn't be able to change my application. You would have access to my application because I wrote it to be a public application, but you wouldn't have access to changing the underlying software unless I made you a developer. Like there's an administration. Wait. Right. Right. Yeah. Yeah, of course. Yeah, you could. App Engine, App Engine serves a request. Right now we only support Python, but that Python is written as a CGI program. So any kind of CGI library that you have access to will work with App Engine. You can write any kind of application that you want. So you can write you know, you should go to and see what people have done. People have been pretty creative in the applications that they're writing. Now, you know, I'm not going to say that, you know, App Engine is perfect for every single type of application at this time, but, you know, there's definitely a very large class of web applications that it's pretty suitable for. So let me just put the URLs up so if people are interested in seeing the URLs. There we go. So it's yeah. Sorry. Oh, just if you go to the first link is the groups link, and that's where a lot of discussions about what kind of applications are out there is going on. If you want, I can put. Do you want me to put up the link to the app gallery? Actually, that should be pretty easy. There we go. Well, that's pretty straightforward. That's what the app gallery looks like. The app gallery itself is a Google application, is an App Engine application that we wrote internally to showcase applications. And I'll just put that up here so that you can